And welcome back as we dive into our first topic here, which is that of the ArrayList class. Now this is going to be something very similar to what we've seen with arrays, but it's going to have a couple of different features and functionalities that are going to be present that we couldn't do with arrays. So as we dive into looking at the ArrayList class, what does that actually entail for us? Well, in Java, we can read in the length of an array when the program is running. But once your program creates that array of that certain length, whether it's 5, 10, user-defined, it's set. You cannot change the length of the array. Now, there are ways to do it that are kind of convoluted that we can go ahead and resize the array, but it's not necessarily something I can just easily add another element. Well, the ArrayList class actually kind of solves that problem of needing to add one more element to a already defined array. So, instead of having, let's say, an element of size 5, and we realize, I need actually 6 elements for this array. Well, ArrayList will let us very easily do this. Now, how this works is that the ArrayList class is actually implemented using an array as a private instance variable. And when this hidden array becomes full, a new larger hidden array is created and the data is transferred from the small array to the new one. And this is all something that happens behind the scenes. You don't have to worry about the implementation of it. We are simply just going to go ahead and use this in our programs. And again, we don't have to worry about this because, again, this is all handled by Java behind the scenes for us, so we do not need to worry about how do you actually handle all these different pieces here because, again, it's just part of the ArrayList class. Now, there are a couple of drawbacks to ArrayList because you might say, this sounds great. We can just use ArrayList for everything. Well, yes and no. There are some drawbacks when it comes to using ArrayList. Now, because you might be asking, okay, well, if an array list is like an array and we have nice added features, why don't we just always use those things? Well, the answer is quite simple. Array lists over arrays aren't as efficient. All right, array lists, because there's actual implementation that has to happen because you're having to copy and recopy arrays. They're not going to be as efficient when we look at runtime analysis versus an array. Arrays are very much more primitive in their structure. Also with ArrayList, they don't have the familiar square bracket notation that we are used to with arrays. And so using ArrayList is sometimes a little bit more awkward than using just an ordinary array and figuring out the new notation that's going to go along with it. And the base type of an ArrayList has to be a class type or other reference type. It cannot be a primitive type such as int, double, or char. And this is sometimes where we run into issues. If we, for example, just want an array of integers, then we'd have to use int, or we'd have to use an array. If I use, for example, let's say a wrapper class, let's say the wrapper class of integers, well, then we could use an array list. But that, again, this is going to take some more implementation. So a lot of the times when you have an array list, it's being used because you are trying to work with a class type object. And as I already mentioned, if you have integer values, you can't use a regular array list for that. You have to use an array because, again, int values are primitive types, whereas the integer class is a wrapper class, and so we could use that. Now, when we look at using the ArrayList class, array lists are used in much the same way as arrays, but there are some important differences. First off, we have to understand that the definition of the array list is not built right into Java. We actually have to import that. And it's in the java.util package, and so any code that uses the class ArrayList has to have the following import statement at the start of the file: import java.util.ArrayList. Now, an ArrayList is created and named in the same way as objects of any other class, except that we're going to specify the base type using a new notation. So array bracket string bracket list equals new array list bracket string closing bracket 20. And you'll notice with these are more of an angle bracket here that we use these. It's not the square brackets that we're used to. It's not the curly brackets. These are more of an angle bracket that we have here. And an angle bracket is going to be the type. So, for example, this was an employee type. We could put in here a pet or a person. Whatever that type would be of that class would go here instead of where we have string. Now, array lists also have a different impact upon resources. Remember, I talked about how they are less efficient than that of arrays. Part of that has to come with the fact that we can set capacity for our array list. We can easily add 1. Well, if we make that default capacity, because we do have to give it a starting size, if we make it large enough, then the system will not need to reallocate memory too often. So like for example, if we say we know that there's going to be, let's say 20 elements and we make it of size 20, then our program should run faster than if I say, hey, it's 5 and I need to get up to 20, because every time I have to add 1, it's having to reallocate a new set of memory to create that bigger array. On the other hand, if we make our capacity too large, we're just going to waste storage space. So if I use that example I just gave and I said, hey, I'm going to have an array of size 20, and let's just say that I set the starting array though to, let's say, size 100. Well, that's going to be a lot of empty space that is not going to be filled, and you could have, of course, condensed that down to fit your data size more appropriately. However, no matter what capacity we choose, whether we make it larger or smaller, we can still pretty much do anything we want with that array list in terms of the different values that we're going to look at and the methods we're going to examine. Now, the first thing we need to talk, though, is about type interference in the base type. Java supports a slightly shorter but equivalent way to define an array list. We just saw how we can create a new one here, but the other format is you use the base type in the call of the constructor, and therefore it's not needed. So if we look at this here, I can say ArrayList string list equals new ArrayList bracket 20, and you notice in these angle brackets right here, we still have them defined here, but over here there is not a type defined. And this, of course, is exactly the same as what we just saw, but there's no type defined here. This is a feature called type inference, and we're going to briefly discuss this in an upcoming lesson, but the thing that we need to know here is that the type string in the previous ArrayList example is a base type of the ArrayList class. And we can, of course, it's pretty much inferring what you see here in this open bracket, say, hey, infer whatever the type is here with this ArrayList. Now, ArrayList is an object of an ArrayList class, which of course as we can see here, and it's going to store whatever objects in that array list that are the base type. Base type, of course, in this example being string. Now, those reference type as the base type do play a very important factor in how we construct these, because you can use any reference type as the base type of an ArrayList class. We can use any class or any interface type, which is a nice little feature that we can use. However, just as we've kind of already talked about, you can't use primitive types such as int or double as that base type of the ArrayList class. It's not going to be very happy with you. And those things that we're passing in are, of course, our type parameters. The ArrayList class is defined having a type parameter for the type of the elements in the list. So if it's a string ArrayList, then those types would be strings. If we want our class to truly be solid, we have to specify in angle brackets a class type to be substituted for the type parameter. So if we look at this one, we substitute string in for the type parameter, and you'll notice it's very similar to what we saw originally. We have ArrayList string list equals new ArrayList bracket with string again 20. So this allows it to be very solid, and it's not having to rely on inference to determine what is. Both will still work. So whether you do the first way or you do this way, both will still work. It's just that each has a small little bit of nuance with the coding that you might have to travel. Now, let's look at the notation a little bit more here. ArrayList objects can be used like arrays, but they don't have that angle bracket notation as we already talked about. So no square brackets. So if you tried, for example, to use a index equals hi mom for an array of strings, then the equivalent substitute for a suitable array list is list.set parentheses index comma quote hi mom. If we were, for example, to have a string temp be equal to the array of the index for an array of strings A, then our equivalent statement for the suitable array list would be string temp equals list.getIndex. The two methods set and get give array lists approximately the same functionality that the square brackets end up giving to arrays. However, we have to be aware that the method invocation list.set index comma hi mom is not always equivalent to a index equals hi mom. So even though they are equivalent, they are not exactly the same. Now, let's actually look at how to manipulate an array list. First off, what's if we want to add an element to array list? Because that was one of the big selling features of array list. We can add things to it, right? Well, when we start looking at that, we have to use the set method. And the set method is how we can replace any existing element. So if we want to update an element in the array, all right, but we can't simply just necessarily put it any index as you can with an array. All right, the method set is used to change the value of elements, not to set them for the first time. So this is a very important distinction. It is not simply, if we want to, finish filling up that array list, we're not going to use set. Set can only modify. So the best way to think about set is it's not adding a value, it's modifying a value. So to set an element for the first time, we actually use the add method. So add is what's going to add in those elements to the array. And the basic form of the method add adds elements in its position 0, position 1, position 2, so on and so forth until that array list is filled. All right. However, our code can always go back and change any individual element just as it can in an array. Now, if our array list is empty for some reason, let's just say we create an empty array list. And let's just say it's of type string and we don't have any elements to it, so therefore our array list is technically empty. Well, if we want to add the strings 1, 2, and 3 to positions 0, 1, and 2, I do list.add, quote 1, list.add, quote 2, list.add, quote 3. And that, of course, allows us to look at the add method and how that truly is working here. All right, now, those examples we just saw were just one version of add. There's also an overloaded version of the add method. All right, it's a 2-argument method that allows you to add an element at any currently used index position, or we can do it at the first unused position. Now, when inserting into an array list with this version of add, the overloaded version, elements at the specified index and higher, if we have any, are moved up one position to make room for that new element. So, for example, if I say list.add 0, quote 0, it will add the string 0 at position 0 and move the elements from positions 1, 2, and 0, 1, 2, and so forth up one position to 1, 2, and 3, and so on and so forth. Now, if we look at this with a little bit of example code, all right, again, you can see here we have list.add 1, list.add 2, list.add 3, comma 0. These 4 invocations of list.add, all right, when this code is done being run, would have the strings 0, 1, 2, and 3 at the positions 0, 1, 2, and 3, respectively. Now, this is great. We can easily see how we can just add code in, but what are the limitations? What are the drawbacks that we're going to have to encounter here? Now, the 2-argument version of add that we just saw with 0 cannot add an element at just any position. It can only insert an element at some point already used or at the first unused position. The elements in an array list always occupy pretty much a continuous set of positions, starting at 0. That is, they're always going to be 0, 1, 2, 3, etc., all the way up until eventually the last point in the array list. The best way to think about this is kind of like a partially filled array. But unlike a partially filled array, you don't need anything to keep track of how many elements are on the list, because again, this is how the array list is structured. Now, what about size? How do we handle size here? Obviously, we know with sizing of an irregular array how to handle that, but when you start talking about array lists, it's pretty easy to find out how many indices have elements simply by using the method size. It's a method that allows us to quickly and very easily determine that. So if a list is an array list and we use list.size, we're going to get the size, which is simply the number of elements that are stored within a list. And the indices of the elements simply go from 0 to whatever one less than list.size is. So if we look at this for loop here, you can see it's just running is less than list.size, and we're just printing out the index here. All right, lastly, let's just go ahead and quickly look at some code here just to show you how this is working. So here I'm just using a predefined variable to set the size of an array list, so in this case 5. And we are declaring that array list with this integer wrapper class, because you notice it is an integer, not an int, because we cannot use primitive types here. And then all we're doing is that we are adding elements to that. So you notice it's doing add of I. All right, I, of course, is just referring to this piece right here. Now notice, of course, this is an int, but that's okay because we are using the integer wrapper class. So even though this is passing an int, we are using the integer wrapper class that will help take care of some of that automatic boxing and unboxing for us. Then, if we want to print the elements in the array list, you'll notice this is a lot easier than necessarily with the array, because I can just say, hey, print the array list. I don't have to have a for loop to go ahead and do that because it's automatically going to do that for me. Now, if I want to remove an element out of the array list, you'll see it removes it, and then I can, of course, print again to see that change. And if I want to print out the elements on a single line, you'll see that in here we have a get method, all right, which will get the elements of those. So let's just go ahead and run this real quick to see how this actually looks. So with our first one, you'll see when we print out the array list, you'll see it gives me a square bracket notation, and then I get 1, 2, 3, 4, 5. After we remove element 3, all right, which of course is at here, which is 4, because remember it's starting at 0, 0, 1, 2, 3, so 4 is removed. And then if I want to print out these elements one by one, you can see that we get the same thing, but these square brackets are now no longer there.